Assalamu alaikum. How are you students? Hope all of you would be safe and sound at your homes. So dear students, due to this current reason and situation of coronavirus, we have managed to have our online classes. So in this regard, I am gonna welcome all of you with core of my hearts that we are here together to have our new strategy for learning. So let's start our topic. First of all, I would advise you people, please open your books. Today inshallah we would have discuss from page number 2 to 5, and the topics you may see here at board. We are gonna discuss these few topics, and inshallah I would try my best to deliver at my perfect level inshallah. And if you would have any query, you would ask me at WhatsApp or any other source, you can contact me, and I would need your feedback as well. So first of all, I am gonna give you congratulations to attending the 10th class first lecture of chemistry. So my students, here the main topic of this chapter is chemical equilibrium. All of you are well aware about the term equilibrium. Okay, so in case of chemical equilibrium, we have to understand some terms here. First of all, you should know that there are few changes. Some are reversible and some are irreversible. For example, if we talk about the equilibrium, so a very simple example I have mentioned here. It is also in your book, textbook. You may have seen the page 2 to 5 here. So you know that plants, they release oxygen, and obviously animals and all other living things, they consume this oxygen for their breathing, and in the result they animals, they give carbon dioxide to the plant. This is a very simple example of the chemical equilibrium, because you know that plants use oxygen to make the food. Previous classes you have discussed that process is called your photosynthesis. Plants use the oxygen for photosynthesis, and they plants use the carbon dioxide for photosynthesis, and in the result they release oxygen. I'm repeating, plants use the carbon dioxide for photosynthesis, and here I would like to mention the chemical equation CO2 plus H2O. Okay, this process takes place in the presence of chlorophyll like that, and in the result we will get C6H12O6 plus oxygen. Okay dear, C6H12O6 plus oxygen. This oxygen is consumed by the animals. Animals take breathe with the help of this oxygen. So this is simple representation of the chemical equilibrium in our atmosphere. Now what happens in the chemical equilibrium, and why we call it an equilibrium? In physics, equilibrium means when the two processes are occurring with the same rate and with the same ratio, we call it as an equilibrium. There are different types of equilibrium in physics, but here we have to discuss the chemical equilibrium. So to understand the chemical equilibrium, first of all you should know that you must be aware about the term irreversible reaction. You know that in chemistry there are two main changes. One change is your physical change, and second one is chemical change. We are gonna here discuss the chemical change. So chemical change may be reversible, may be irreversible. In our surrounding, most of the changes, they are irreversible. Most of the changing taking place in our atmosphere, in our surrounding, these chemical changes are irreversible. Now what are irreversible changing? For example, I am gonna give a simple example. For example, we are gonna burn the carbon. Okay, in the place of oxygen, what you would get? In the supply of open air, you would get carbon dioxide. Now it is difficult, rather impossible for us to get the carbon and oxygen back from the carbon dioxide. So this is a very simple example of the irreversible change. What? Irreversible change. Irreversible change. Okay, mean We cannot get carbon and oxygen from the carbon dioxide. So in the irreversible change, such change in which the left, okay, now in the chemical reaction we have main two things. In any chemical reaction we have main two things. One is called reactant and other is called product. Okay, the substances that are mentioned at the left side of the arrow, they are called reactants. They are called reactants, beta. Okay, and at the right hand side they are called product. They are called product. Okay dear. So what happen in irreversible reaction? In irreversible reaction, reactants are changed into product. Reactants are changed into product or products, you can say. Okay, and there are few properties of irreversible reaction, that they almost complete. Okay, mostly the reactant they almost complete into product. We represent them with the single direction arrow. Okay, why single direction arrow or single directed arrow? Okay, so this is the irreversible reaction, such reaction in which products cannot give us the reactants, or we cannot get reactant from the product. Okay, then afterward we have reversible reaction. What is reversible reaction? Okay, in your textbook they have given the okay, another example that has been mentioned in your book, it is the formation of water for the irreversible reaction. Another example I have mentioned, a simple example, you can give this, but for your textbook they have mentioned this example of formation of water. Formation of water is an other example of a irreversible reaction. It is also irreversible reaction. Okay dear, because it is impossible for us, it's very difficult for us to get back the hydrogen and oxygen from the water. So heat, they have mentioned here heat. Okay, it is an exothermic reaction. Heat is released. You can also write here, or you can also write after that plus delta H, mean heat is released, plus delta H. Okay, plus delta H mean heat is released. So this is also example of irreversible reaction, and number of examples are there which are you can give in case of irreversible reaction, but for your syllabus point of view, two examples are enough. Then what are reversible reactions? The reversible reactions are those in which reactants are converted into product. Reactants are converted into products. Reactants are converted into products. First thing, reactants are converted into product. Reactants are converted into product. Number one. Okay, reactants are converted into product and vice versa. Product are also converted into reactants. Reactants are converted into products and product will be converted into reactants. This is very simple example of formation of hydrogen iodide. Okay, secondly, these reactions never complete. Secondly, reversible reaction never complete. Okay, and they attain the state of equilibrium. They attain the state of equilibrium. Thirdly, they are represented by double-headed arrow. Okay, two direction or double-headed arrow, and one arrow it will indicate the forward reaction. Okay, FR stands for forward reaction, and in the reverse reaction, RR you can say rate of reverse reaction or reversible reaction, or backward reaction you can also find in some books in backward reaction. Okay, the reaction in backward. So it is two direction reaction, while the reversible reaction it is single direction reaction. Got it? So reversible reactions are those reactions in which products react to form reactants, and reactant they react to form product. If we have a typical example in your syllabus, in your book they have given the simple example of formation of iodide. Formation of iodide. What happens here? If we take the two flasks, okay, in one flask if we are gonna take mixture of hydrogen and iodine, mixture of hydrogen and iodine. The color of iodine is purple. Okay dear, the color of iodine gas, it is in purple. It is purple. Okay, when we are gonna mix them, when we heat the mixture of hydrogen and iodide, we get hydrogen iodide. We get hydrogen iodide. We get hydrogen iodide. Okay, and this hydrogen, the color of iodine is purple. The color of iodine is purple. The color of iodine is purple. Mostly it is asked in the exam that what is the color of iodine. The color of iodine is purple. And with the passage of time, when there is the formation of hydrogen iodide, its color start to fade. Okay, hydrogen iodide is colorless. It is colorless. It's colorless. So with the passage of time, the purple color start to fade. It means that change in color, it would indicate that there is the formation of a hydrogen iodide. So this is again, if we are gonna discuss only in single way, this is forward reaction. This is forward reaction. Okay, but if we again heat this hydrogen iodide, okay, if we are again heating the hydrogen iodide, then you would say we would get what? H2 plus I2. In this case, the fade color of hydrogen iodide, it would convert into purple color, because in that case you would get the iodine. So in first case, hydrogen and iodide, they are reactant. They are acting as a reactant here. They are as a reactant, and hydrogen iodide is product. In second case, hydrogen iodide is reactant and these are the product. Okay, but if we are gonna heat them, this mixture in a container, this mixture in a container that is closed. Okay, if the container is closed, then you will see that the mixture of hydrogen iodide, it will provide, in first stage we will get hydrogen iodide. In first stage, when we are gonna heat the mixture of hydrogen iodide, we would get hydrogen iodide. After getting the hydrogen iodide, if we again heat that flask, then again there would be decomposition, and in case of decomposition you would get purple color back. So this diagram indicates that if the reaction is gone a forward direction, okay, this it would be your combination. Okay, combination. Okay, and here you would get dissociation. Okay, combination and dissociation or decomposition, you can say. Here in forward reaction, when hydrogen and iodide, they will combine, they will give us the hydrogen iodide. And secondly, when we will get this mixture, when we will get this product, okay, and again we will heat it, then we will get what? Hydrogen iodide again. So what happen if we are gonna continue this process in a closed container and we place this flask at the heat, then a time will reach, then the forward and backward reaction, they would take place with the same rate. The number of molecules that are going to convert into hydrogen iodide, it would be equal to the number of molecules that would convert from the hydrogen iodide to the hydrogen and iodine. So this is again the characteristic of chemical equilibrium, that rate of forward reaction would be equal to the rate of backward reaction. So now at the left hand side it is represented as reactants, and the right hand side we would treat them as a product. So this is the typical example of the formation of hydrogen iodide. Another example that has been given in your book, it is the decomposition of calcium carbonate. Let's discuss that example also. Decomposition of calcium carbonate. Decomposition of calcium carbonate. Decomposition of calcium carbonate. Okay student, now take another example. Okay, second example, there is, you know that there is the formation of calcium carbonate. When calcium oxide is treated with carbon dioxide, we get calcium carbonate. Okay, in mostly you have seen this calcium oxide in the different shops that which is in local language you call it as a tuna. Okay, and it has also you have also seen it when we pour this calcium oxide in a water, we get the bubbles. Okay, जब इसे calcium oxide को पानी में डाला जाता है, चूने को अगर हम पानी में डालें तो बहुत ज़्यादा उसमें bubbles निकलते हैं. So this is the reason that during the formation of during the decomposition of calcium carbonate, okay, when this calcium carbonate decomposed into calcium oxide, there is the 900 degrees Celsius temperature. When the calcium carbonate is decomposed, there is the 900 degrees Celsius of the temperature. Decomposition needs, here I am going to mention, decomposition need 900 degrees Celsius, 900 degrees Celsius temperature. So it means this calcium oxide, it has in it that much temperature. So here another example, if we took calcium carbonate in a flask and we manage it to heat, then if the flask is open, then that reaction would be irreversible reaction, because carbon dioxide it would escape and you would get only calcium oxide. As in case of your different furnaces where this reaction is carried out, mostly they skip the carbon dioxide, or they can also use that carbon dioxide in other processes as well. But if the reaction is irreversible, you would get only calcium oxide. That's why we have mentioned here irreversible reaction goes to completion, and that reaction it would be goes to completion. But if in the same case, if we close the container, if we close the container calcium carbonate and we are gonna heat the calcium carbonate, then again calcium oxide it would again react with the carbon dioxide would react with the calcium oxide to make the calcium carbonate. So here these equations are indicating that if the container is open, because in the open system, in open container, we are unable to get the equilibrium state, chemical equilibrium. It is the prerequisite for the chemical equilibrium, dynamic chemical equilibrium, that the container must be closed. So calcium carbonate it would convert into the calcium oxide and the carbon dioxide. But if the container is closed, then calcium carbonate first process it would be forward reaction. It would be your decomposition. Initially the rate of forward reaction would be greater, because more and more calcium carbonate you would have number of molecules of calcium, number of parts of calcium carbonate greater the number of mole of reactant, you would get the greater the rate of forward reaction. With the passage of time, the rate of reverse reaction will start to increase. Firstly the rate of forward reaction would be greater, but with the passage of time rate of backward direction it will start to increase, and a time will come when the both rate of forward and rate of reverse reaction they become equal, and we call it that the equilibrium has been established. So in reversible reaction equilibrium is established. Next we have written here static equilibrium. Static equilibrium, it is a type of equilibrium in which all the forces acting on a particular object are same. For example, the building, that is the stationary building, the building is a good example, because the building is on it has all the forces equal. Standing building is a good example for the static equilibrium. In case of dynamic equilibrium, rate of forward reaction would become equal to the rate of reversible reaction. So inshallah dynamic we would again discuss this dynamic equilibrium in our forthcoming lecture. I hope you have got these all things. Stay blessed, and I would wait for your queries and wait for your questions and your feedback. Assalamu alaikum. Okay students, now at the end I would advise you, please note down these MCQs so that I can judge that how many of you have got my lecture, and I am giving you the few minutes, and beside this I am also going to read these MCQs and so called your short questions. In first MCQ is there, The formation of rust is an example of dash reaction. The formation of rust is an example of dash reaction. We have the option A, irreversible, B, reversible, C, decomposition, D, none of these. In second MCQ, note it, is an example of reversible reaction. Is an example of reversible reaction. Four reactions has been given here. A, hydrogen plus iodine makes with single arrow hydrogen iodide. Nitrogen plus hydrogen with double arrow makes ammonia. Calcium carbonate CaCO3 arrow single arrow CaO plus CO2. Option D, H2 plus O2 arrow 2H2O. You can balance it as well. Number 3, the color of hydrogen iodide Hi is, the color of hydrogen iodide is A, pink, B, blue, C, yellow, D, colorless. 4 MCQ, the product of combination of CaO and CO2 is, the product of combination of CaO and CO2 is, option A, water H2O, option B, calcium carbonate, option C, carbon dioxide, option D, CaO. It's your fourth MCQ. Then we have two short questions that may be asked in your board paper from these few pages. Number 1, define reversible and irreversible reaction with examples. You have to write the example with reversible as well as with irreversible. In my lecture you may see these examples, and these are also mentioned in your book. So these are, you can write these questions from your book, and you can send after solving this paper, this MCQ and these short questions to me. Then I would check them, inshallah I would give you feedback. Number 2, write down the chemical equations of reactions of hydrogen iodide formation and calcium carbonate formation. You have to only write the equation, that how hydrogen iodide is formed with single arrow or double arrow, but you have learned, and how calcium carbonate is formed. Okay, so here I would suggest that you should write with a single arrow. So each equation would have 1 mark. I hope that you have understand, and inshallah I would wait for your feedback, that how many student would send me after solving this short paper or short query. Okay, stay blessed my dear students. Assalamu alaikum.